Hi, and welcome to the final part of Advanced Data Journalism Doing More with R, Module 4. In this first section, we're going to be talking about statistics and how to incorporate them into your stories. Not only how to do them, but also how to shape the language so it makes sense for our readers. This is by no means going to be an in-depth thing because we're going to be moving on to maps right after this. But I wanted to give you all an overall sense of what is out there. And if you're interested, you can go and dig more into more statistics-based analysis using R, okay? So it's still good to know because you really have to understand the data that you're working with and understand all the different opportunities and pathways you can take when you're analyzing data. And to do that, you really have to understand the structure of the data you're working with, all right? Because the more you understand it, the more paths open up. So you need to start out with a data set, and I'm going to use this Fatal Force data set that the Washington Post tracks and posts daily of all the police shootings across the country. We've been doing this since 2015. And this is data that you can just grab that we share on GitHub. And pulling in the data, you want to take a look at what the data you're working with. You've got the names of every shooting victim, you've got the date they were shot and killed, manner of death, and all these other variables like age, gender, race, signs of mental illness, so on and so forth. All right, so the first type of data that you want to look for, that you can do analysis with, is categorical data. All right, and with that type of data, you can do frequencies, counts, and crosstabs. Categorical data includes data such as gender, race, all right? So we can start out with bring in the package for Lubridate, because what we want to do is we want to create a new variable eventually off of, let's say, the date, because we want to grab a year. So you can create new categories if you want. So let's start out with Fatal Force, so we can do some frequencies counts. So we're going to group by signs of mental illness, which was down here. And we know that's either a true or false. So we group by that, and we can summarize and create total equals n, and then we just get frequencies of how often true or false showed up in the signs of mental illness column. So you can see false happened most often. So if we can do crosstabs, which is kind of the same thing, except we add more groups. So we're not only doing signs of mental illness, we're also adding the variable armed. And armed is, you know, what they were armed with and when they were shot at the time. So gun, toy, unarmed, whatever. And so we just add a second thing in there, and then we just tally it up, and now we've got an expanded crosstab. Okay, and that's basically all the cool stuff you can do with categorical data. Those are some examples. All right, so what if you have continuous data? So instead of these different, you know, true or false, 0 and 1s, where there's just 1 or 2 or a handful of things that is consistent across all of them, there's something called continuous data. And if you look back at the raw data itself that we brought in, an example of continuous data would be age, okay? Because those are just, you know, there's a range of it. And what you can do with continuous data is you can calculate mean from it, you can calculate median, you can calculate the range, and you can calculate rank. Those are some of the things you can do with continuous data. And so from those things, you can do stuff like calculate disparity or comparison or change in time. But that's the type of stuff you can do on continuous data. So let's start out with the Fatal Force data again, and we'll just simply summarize on the continuous data to figure out the mean, the median, the min age, and the max age. And so now we can see 37 is the mean average age, 35 is median, minimum, the youngest age was 2, oldest age was 92, shot by police. So there's more stuff you can do with continuous data. You can create n tiles, you can do rates, you can do correlations, and you can do regressions. So here's an example of creating some n tiles. This time I'm going to bring in some population data, because we're going to do a lot of this stuff. So bring in state population, it looks like this. It's just name of the states, abbreviations, and the population for every state. So then when I get Fatal Force data, what I can do is I can group by state this time, the categorical state, and then summarize and count up the number of shootings by state, and then join to this data frame the state population data, And from this, I can now calculate a rate, the per capita, how many people have been shot by police when normalized for the population. So per 100,000 residents. So I took shootings divided by the population times 100,000. And then you get this number here. Now, what if I wanted to figure out, add an extra category to like group up these states together? What I can do is I can use this function called ntile. And what it does is I want to group up all the different states by the different buckets of population sizes. So and I want to divide into 4. I could do 5, 10, whatever. So this is saying all the ones are the states with a small population, right? DC, Delaware, Alaska. And then the higher ones, California and so on, and Florida, those are the 4. So it ranges. So it buckets them up in like 5 different, 51 divided by 4. So it divides them all up into 4 different groups and labels them by 1. So now when I group them up by ntile and add, so I've done some categorical analysis, then I mix it up with continuous analysis, and then I went back to categorical analysis so that I can then do some continuous analysis on that. Continual analysis. So I can figure out the average, what is the average per capita shootings by population size. So you can see here, in actually urban areas, they shoot people less often per population than they do in the smaller areas. Okay, interesting. So some potential story ideas. Next thing you can do with statistics is you can explore relationships between variables. Okay. So one tool that's used a lot is linear and logistic regression, which is kind of measuring the relationship between variables, which is useful for inference and prediction. Inference asks how accurate is our estimate of the relationship between variables, and then prediction is how accurately can we predict the outcome of a variable. Okay, it's a lot to wrap your head around. So linear is when you use continuous. Logistic is when you have discrete, categorical, or binary data. So linear regression, logistic regression. Let's jump over to correlation real quick. So here's an example of a story that used correlation recently, looking at coronavirus cases reported in the weeks before and after states reopened bars. All right, so after we were looking at it, you could see these are all the different red bars represent the number of cases over time. These little gray dots represent when bars reopened and then when they reclosed. So if you look individually at these states, you can see some of them started increasing. The cases started really increasing after the bars reopened, and then in some cases they started decreasing after bars closed. All right. So how can you measure that? So what I did was I took the percent change in foot traffic 1 week after bars reopened compared to the change in cases per capita 3 to 4 weeks after bars reopened. So I didn't look at them on the same dates. I had to stagger it and lag the dates, because assuming you go to a bar, you get infected, it's going to take, maybe 2 to 3 weeks before 1 to 2 weeks before it shows up in your system. So, or maybe 3 to 4 weeks after a week after that, because you're going to get tested and it takes a while to get the results back then. So you could see when you put those all together, there seemed to be a relationship, a trend line between that. And so what we could say is, states that have reopened bars, here we go. So not the highlighted stuff, but the chart here says, suggests that there's not a strong relationship between, So I said there is some relationship here. We found a statistically significant national relationship between foot traffic to bars 1 week after they reopened and an increase in cases 3 weeks later. But then we had to dig a little bit deeper and say, actually, it's not that significant when you look at it state by state. But I did say that states that have reopened bars experienced doubling in the rate of coronaviruses 3 weeks after the opening, on average. Okay, so there's 3 different levels of statistics that I used here. One was kind of like this correlation type of thing, which was, which is okay. But I had to shore it up with using this crosstab of experiencing double the rate, so I just, create a crosstab of like what was the rate before and then what was the rate after. And then I just compared the two, and I could see it's double. All right, so that is an easier way and for a reader to understand. And so I would use that instead of talking about relationships, because correlation does not equal causation. That is the biggest thing. So did opening bars cause a rate doubling of COVID? You can't really say that for sure. There's a lot of confounding factors, right? This might have coincided with a bunch of other things opening up, not just bars. It could have been like maybe more tests arrived, so people were more accurate or testing more regularly. There's a lot of different things in there. So that's why it's really difficult to say. And so that's why, in this graph, we led with the more solid relationship, solid thing we could say with statistics, and then the less strong stuff we kind of saved, put at the bottom. So, I want to talk about linear modeling that has been done in stories. Recently, the Post wrote about looked at the flawed data of countries reporting their emissions, because they pledged the Paris Accords that we're going to lower our emissions by X amount. But how are they measuring their emissions to start with? And so what they did, reporters did, was they created a model to estimate that emissions each country would have reported in 2019 if they reported in an earlier year. So, because there's a lot of missing data. So the Post used linear regression technique to model what countries would have reported in 2019, based on their reports from the past, and then a bunch of other fill in the blanks from other things. So that's another benefit of creating a model. And so some advice for if you're working with statistics. You got to be really careful. So, list of things to do. Most of the time, the uncomplicated process is better for the reader to grasp, okay? Just because you did a lot of techniques just to investigate, it's just like you're reporting. You're not going to put everything from your notepad into your story. You're not going to dump your notepad. It's good to curate. It's good to think, what is your reader's needs? What are your reader's needs? And usually it's the simpler process. So if you can if you figure out that, there is a relationship in this, between these two variables, there might be another way, once you've confirmed that, to go back and be like, okay, what is a simpler way to break that down into these different pieces for the reader to understand? Next thing that's really important is to explain your methodology. Okay, it's really important, especially in this time of age where people are just kind of attacking they're going to naturally attack your biases or your if you have any hidden agendas. So the more you put out there like, hey, this is what I did, this is how I did it, the less they have any ammunition to attack you with. So also you can save the complicated numbers for your graphics and simplify in sentences for your story. Also, please be in constant communication with the experts, the topic experts in the field, all right? And, have a conversation back and forth with how you're doing it, test, have a gut check on what you're doing with them. Avoid spurious correlations, okay? So if you can, avoid correlations entirely, but obviously, if you're going to try to put in your story, make sure that it's really solid, okay? Also, explaining statistical significance is difficult, and that might be just altogether easily more avoided. So, I just wanted to run over those points for you, because when you go to the exercises now, we're going to talk about a couple of different methodologies I want to show you. One of which is exploring relationships between two different time series of data sets. One data set being COVID data, and the other data set being Amazon candle reviews. So notice how that all syncs up with your previous module where you were scraping data from Amazon. Well, here is some interesting and possibly relevant uses for it. All right, and then last thing I'm going to show you is how to use linear regression to investigate a payroll to see if there's any disparity with any kind of among the employees, right? I feel like that is going to be really, really relevant these days. So I hope you take these exercises and really absorb them and learn them, all right? And then that'll be it really for the statistics portion of this whole advanced data journalism class. We're going to move right into mapping next, which I think is really, really fun. And there's so many new tools out there that I hope you can play around with. All right, I'll see you soon.